Hello and welcome to today's workshop. My name is Fahad, and today we'll be building an AI that's able to analyze movie reviews using TensorFlow. Our dataset will contain about 50,000 movie reviews from IMDB, each with a review as a sequence of integers and a label of whether or not the review indicates a positive or a negative review. Before we start, let me actually tell you a little bit about the assembly and what we do here. The assembly is a smart lab based out of In5 since December 2014. We have over 300 free workshops done, and the workshops mainly focus on three main topics. Hack, which is for embedded systems, IoT, and hardware, so you can think of things like Arduinos and Raspberry Pis. The code workshops actually for software projects, so we use APIs, frameworks, and we create certain apps. And of course, today's topic, data science, which we cover topics related to AI and machine learning. Our targeted audience are students, professionals, and entrepreneurs, but really our videos are available for everyone who's interested in these topics. You can follow us and tag us on our social media at Make Smart Things on Facebook, Twitter, and Instagram, and here on YouTube at The Assembly. So let's actually talk about the activation functions we're going to be using in today's workshop. We have two main things we're going to look at, ReLU and sigmoid. And remember that the activation functions tell each neuron what to do with the result. So the ReLU activation function actually returns the maximum value of 0 and the output of that neuron. So if you have anything negative, it's going to be pushed to 0, and anything positive will keep its value. Whereas the sigmoid value actually tends to push the outputs from 0 to 1. So if you can look at the graph on the right, you'll see that the sigmoid activation function actually pushes anything that's less than 0.5 more towards being 0, and anything over 0.5 to going more towards 1. And this is really helpful in binary situations like what we're going to look at today. Moreover, we're going to be using loss function optimizers because it's a backpropagation. So for our loss functions, we're actually going to look at binary cross entropy because, again, we're predicting whether or not something happened. And loss functions are really helpful because they calculate the error in your weights. So eventually, the optimizer will actually look at your error and help optimize the weights in each neuron for a more accurate prediction. And for the optimizer, we're actually going to be using the Atom optimizer today. So today we'll also be looking at a TensorFlow Keras layer called the embedding layer, which actually takes integers. And keep in mind that our reviews are actually a sequence of integers instead of strings or words. So it's going to take these integers and actually turn them into vectors. And what's nice about this is there are many dimensions. So today we'll actually be looking at 16 dimensions for a vector space. And the distance between two vectors, or exactly where they're placed on the vector space, tells us something about it. So for example, if we have the words good and evil, they'll actually be very far apart if we look at their vectors individually. But for something like good and great, they're actually going to be much closer together in that vector space. Again, we'll see how we'll put this into our code later. So finally, let's look at our dataset. So our dataset will actually have 50,000 movie reviews from IMDB. Each review row actually contains the review itself as a sequence of integers. Again, these integers mean nothing to us, but we can actually write a code to actually read it in human language. And also a label. So if the label is a 0, that means that the review actually indicates a negative review, and a 1 indicates a positive review. So now we can begin coding. So let's begin coding. So if you open the Python file we gave you, you'll actually see a document similar to this in whatever IDE you're using. We also gave you an IPYNB file, which you can open on Jupyter Notebook, or Google Colab. Now I'm using the Python file because I actually want to be showing you guys a variable explorer option and how everything looks like when we load them in. So here, let's first actually start by importing our NumPy and TensorFlow libraries. So we're just going to import NumPy as NP, and we're going to import TensorFlow as TF. Let's run these two files, and TensorFlow actually takes a second or two to load. And there we go, TensorFlow and NumPy already there. Now, before we move on, let me actually show you some functions for our dataset. So we're going to be using Keras.datasets for our IMDB dataset. And what's actually important to us is some of these parameters that are actually already there. So the start character is already set to 1. Let's see what that means. So the start of a sequence will be marked with this character. So for every review, they're all going to start with the integer 1. And keep in mind, when we load our dataset, it's just going to be a sequence of integer and not a sequence of words or characters. So that's what start char means. The OOV character actually stands for out of vocabulary. So it's saying these actually aren't in our dictionary, so we don't know what those words are, which is fine as long as we label them with the number 2. And finally, index from, here they tell you it starts from 3, so everything starts mapping, every word starts with a key value of 3 and more. So once we know what these are, we can also look at num words, which is the last one we're interested in. So we can actually set it to an integer or none. So if you give num words an integer like 10,000 words, it's only going to load the 10,000 most common words that were used in every review. But for us, we might as well just use all of the words. So if you set num words to none, you will just load all of the words in your reviews. So let's actually do that now. So let's load our dataset. So we're just going to say data is equal to tf.keras.dataset.imdb. And we're just going to run this. And to load our data, let's actually look at one more thing. Here, for the load data function, it's actually going to return a tuple of NumPy arrays. So it's going to return them in this form, so why not just copy paste this here. And let's say this is equal to data.load_data, and we don't need to change anything. The default settings are enough for us. This is actually going to take a second to load, so we'll see once it's finished loading. Alright, and we're back, and as you can see, the test set and the test labels, training set and test labels are all loaded. And let me actually show you what they look like. This is also going to take a second to load, so we'll see once it's loaded. Okay, so everything's loaded here, and as you can see, for the features of our test set, all these numbers actually start with 1, and then you can see a large sequence of integers. Again, we don't know what this means because we don't understand. This is like more for a model to learn from, but for us, we actually want to read it as a sequence of words, so we're just going to write a few functions that will help us do that. But as you can see, they all start with 1 because we said that the start character is 1, and every integer after that maps to a word, which we'll see what that means in a second. So first thing we need to do now is to import our dictionary. So it's going to map each word to a certain integer, so we can actually see what that looks like. If we do word to int is equal to data dot, we're going to call the get word index function. And again, the documentation is available here. All you have to do is click this, and I'll show you everything you need to know about this function, which is pretty simple. It just has a path, which we don't need to change. So once we call this get word index function, you can see that every word, such as fawn, zucchino, nunnery, these all map to a certain integer in our dictionary. Now, if you remember, when we looked at the load data function, we want all of our words to map to an integer, but the integers actually start from the index 3 and not the index 1. So what we're gonna do here is we're just gonna take our word to int, and we're gonna actually modify it using simple Python techniques. So we're gonna say every key is mapped to its value, but shifted by 3. For every key value in word to int dot item, since this is a dictionary. So when we run this code, you can see that fun here at the top right maps to 34701, but once we run this code, it's gonna shift everything to 3 by 3, I mean. So fun now maps to 34704. Now we did create 3 more spaces which we need to use. So let's actually let me write a bit of code first, and then we can actually explain what this code means. Okay. So first we want to make some new characters. So our first character will actually be the padding character. I'll explain what that means. The next word we actually want to be the start, and this is going to map to 1. Again, we read this in the documentation, so we're just going to leave it as that. We're going to put unknown as 2, again because maybe those words weren't loaded, or maybe they don't make sense and they're not in our dictionary, so we'll just leave it 2. And we're going to leave unused for 3 as per the documentation. Okay, now when you look at our dictionary now, it actually maps a word to an integer. Now we actually want something that will map an integer to a word, so we're just going to write a quick line of code that will actually flip this apart. So we're going to say int to word is equal to, so we'll make a new dict, and the dict will be value key for key value in word to int dot items. So again, it's a very simple line of code. You just have to look at it a bit deeper. So you're going to take every key value from word to int, and you're going to make a new dict that's going to actually be value and key. So this essentially flips everything, every word and its integer. So we can actually see now we have a new dictionary called int2word, and there's an integer that maps to a word, as opposed to before we had a word that mapped to an integer. Nice, and finally we can write our decode function. So we're just gonna call it, let's call it decode review, and we're gonna pass it to text. So we're just gonna return, it's just a simple Python function, so we're just gonna join. So we're gonna look at int2word dot get. Now for the get function, we can get I, but if I isn't there, then we can just return a question mark. So if I doesn't exist, and I'll tell you what I is now, let's actually write the code first. So we'll say for I in text. So what this does is going to go through your text and try to see if every word in that text exists in our int2word, or every integer in our text actually maps to a word, and if it doesn't, it's just going to leave a question mark there for you. Right, so let's actually run this. Oops. Okay, so now we have that function ready, and we can actually see what some of our reviews look like. So let's just print. We can take our xstring set. Sorry, we need to call a function, so we call decode review. So we call xtrain 0. And let's actually see what xtrain looks like before. So decode, without decode review. So it's just going to be xtrain of 0. So we'll print these both back to back, and we'll see what they look like. So as you can see, the first one actually started with all of these integers, which made no sense to us, but then when we actually decoded the review, we can actually see that this is a full-on review. So this person saying this film was just brilliant, casting, location, scenery, story. So you can actually tell that they liked the movie. And here we can actually see that in our training set, the first index is a 1. So that means that this is a positive review. We'll get more into this later. Now, we actually come across another problem, is that when people write reviews, they are not limited on a length. So they can be writing reviews of 1,000 words, they can write 100 words. We don't know what that is. But since we're making a neural network, we actually have to define a length for each review. Now, when reviews are too long, what we can do is we can just cut out the end of the review after a specific length. But when a review is too short, we can actually use this padding character that we defined earlier. So what's nice is that there's a library in Keras that you can find. So let's change our training set, and I hope the code makes all of this make more sense. So we'll take our training set and we'll say tf.keras. Let me actually look for the library. It's actually the, I think, pre-processing library, right? And then sequence dot, and then the function is called pad sequences. Now you can see here that first it's asking you for a sequence, so what are you planning to pad or cut out? So for sequences, we'll make this equal to our training set, obviously. For max length, we can put really whatever number you want. I tried 300 and that worked well for me, so I'm just going to keep 300. Data type in 32 should be fine, but for the padding, we actually wanted to pad after. So if it won't make much of a difference, but it's just nicer to see. So if the review is actually shorter than 300 words, it's gonna put these padding characters after the last word in our review. So we're just gonna say padding is equal to post. And then finally, the value we want to pass is going to be our word to int, and we called it pad. Nice. So if we run this, actually let me also run it, showing you what I mean by padding. There's a key error here. Oh, I know why. Okay, so the reason why we actually got an error here is because I didn't run this part of the code. So let's actually run that, which is why also, if you guys remember, here we actually got a question mark because it was we didn't run that part of the code. So if we run this now, it should run. Okay, don't do that. Okay. So it actually didn't run because I ran part of the comment without the starting part of the comment. But yeah, so you can see that because the length is actually shorter than 300, it's going to be padding everything to make it 300 at length of 300. So it's just gonna keep putting these zeros at the end, right? Which is a very simple technique, but very useful for us today. Also, we're just gonna do the same thing for the testing. So let me just, sorry, for the x test, sorry. X test equal to, we're just gonna copy paste this line again. I'm gonna paste that here, but remember to change this to x tests. Let's just run this as well, and we're done. So we can actually also see what this looks like. So we can print x test of 0, for example. Right, so it's just gonna take that, it's a pretty short review, and it's gonna pad everything that's missing with a 0. It's not that it's missing, it's that it's just too short to feed into our neural network. So finally, what we can do now, we can actually start building our neural network. So first thing we do is we're just gonna save everything in models. So we're just gonna call the tf keras models.sequential. Basically, if you remember, sequential just means that one layer feeds into another, that feeds into the next one, and so on. So that's what sequential class means. Everything moves in some sort of sequence. And then if you actually remember when we spoke about the embedding layer, if you look at the documentation, it tells you that the embedding layer must be the first layer of your network, which is why we're adding it here. So we'll just use the model.add. So when you call the add function, it's gonna tell you to add a neural network layer. So we want to use the keras.layers.embedding, right? And for embedding, we have two important parameters we want to look at. So it's the input dimension and the output dimension. Now the input dimension is actually the number of words that you have, which we can see here is about 88,589. So we're just going to say input dimension is equal to let's just say 88,500, and then output dimension. Now you can actually try different numbers here, but I tried 16. That works really well for me. And again, remember, like, this is 16 dimensions, so you're gonna get a vector of like 16 different rows. So now I just got that out. Okay. So having an output dimension of 16 actually, it's very big. So it's going to be computationally really expensive. So what we need to do is we need to, if you're familiar with convolution neural networks, to actually flatten everything. But this is a similar technique. It's called average pooling. So we're just going to add this layer. So I'll tell you what it does in a second. There's dot global average pooling 1D, and there we go. So it takes these vectors and just maps them to essentially an int because it's 1D, right? So it's gonna take an average of all of them, like of all of the 16 dimensions you have, and just return that. And finally, our simplest layers, which are dense layers, which basically, if you think about it, you have your inputs, you have your hidden layers, which are usually dense layers when you think of the entire picture, and your output layer is also a dense layer. They're just interconnected, right? So we want to add one dense layer. Sorry, I'm just going to call model.add tf.keras.layers.dense. And again, you can change its value. I tried 32, and that worked well for me. And for the activation function, we're actually going to use relu because it works really well. Again, if you want to try other activation functions, see how it actually changes your outcome, feel free. You might even get a better accuracy than I will, which we'll see in a second. There are a lot of parameters you can change. That's the fun about deep learning. And finally, we'll add one more dense layer, which is for our output. And because we only want to predict whether or not it's a good review or a bad review, we'll only have one neuron in that layer. So again, we'll call, oops, this is missing that, you're missing this. Okay, sorry about that. So just add model.add tf.keras.layers.dense. Units, again, we'll set it to 1. And for the activation function, we're actually going to be using sigmoid, because if you remember earlier, I explained that sigmoid pushes a value to 1 or 0, which is what we like. Because again, this is a binary sort of prediction, so we're only predicting whether or not they like a movie. So sigmoid is very, very powerful in this case. Now we want to compile actually our network, so we're just going to call model.compile, and then we can actually see everything we need. So first thing you want to show is the optimizer, which we'll be using Adam. It works in many cases. So if you want to read more about optimizers, you can read the TensorFlow documentation. It's very helpful. For our loss function, we explained that we'll be using the binary cross entropy function, because again, we're only predicting zeros and ones. And for metrics, I just want to see, accuracy. And again, you put this in curly brackets because you can actually print more than one metric. So let's actually run our code starting here. I think we didn't run any of this. Right, so that's compiled. And now we actually want to train our neural network. So what to do is we'll call the model.fit. And when you see okay, so we can actually see the parameters here. So it's saying it wants x and y. So we'll say x is x train and y is y train. That's simple enough. But now for a batch size, again, you can try whatever you like. For me, 1,000 worked well. So I'm just going to stick to 1,000. You guys can try anything else really. Epochs, I tried 50. Be careful, don't put too much because you don't want overfitting to happen. Verbose is fine. I don't want any callbacks. But for validation splits, which is always nice to have, so I'm going to try a validation split of 0.2. So this is just going to take so our training set and take 20% of it to validate. So it's going to train with 80% and then validate its training with the other 20%. And when we run this code, actually, this is where we actually made a small mistake. So I'm just running the code again, but if you didn't run this part yet, then you should be fine. But we had some words that actually mapped to over 88,500, which gave us an error when we tried to fit it. we actually had somewhere around 88,588 words. So just make sure you change that to this. Another way you can actually make sure that doesn't happen is when you load the data, just make sure you change numwords to 88,500 if you want to use that here. But again, let me just run the code all the way to here, which is what we just wrote. Oops. Sorry. So just gonna do all this again, which might take a second. Okay, and after everything loads, so now we can see our model actually training, and I'll see you once it's finished training. So we can actually see our model finish training, and we reached an accuracy of about 99.3% and a validation accuracy of 89%, which is actually really good for today's workshop, considering we didn't use many complex layers or connections and all that. This would actually work pretty well, and I'll show you how we can actually test it ourselves in a second. So what we want to do is I want to go take a random review from the IMDB website and ask my model to predict whether or not thinks it's a good review, right? And by good review, I mean like a positive review about that movie. So, but first, obviously we're going to take text, and we want to encode it into a sequence of integers, just like how we got the data in the first place. So what we're going to do is we're going to write a function called encode review, and we're just going to take a random text. And what we want to return is something called, let's call it encoded, and we'll make it empty. So again, every review should start with the integer 1, as we read in the documentation. So we're just going to append 1 first. Nice. So now we're going to say for every word in text, we're actually going to check if word.lower. Again, everything's case sensitive, so it's better to check lowercase words, because everything in our dictionary is actually lowercase, which we can see there. So if our lowercase word is in word to int dot items, so if it actually exists there, then we're just gonna append encoded dot append word to int of that word that we just found, right? So what this does is it's going to check your word, and it's going to check the dictionary. If the word exists there, it's actually going to append the integer it maps to. And again, else if we don't actually find our word there, we're just going to encoded.append 2, because if you remember, we said 2 means unknown or out of vocabulary. Nice, and then finally, after we finish that for loop, we just want to return encoded, which is perfect. So we've written our last function. And what this does is basically, I've written a small bit of code for you that you can actually pass a text file. Let me just open it up here. So I have everything saved on my desktop, and it's in the assembly workshop 2. Okay, so before we do that, let's actually make a new, we actually can't add one here, I think. Actually, we can. So we can actually add a new, now we're just gonna make a text document. And we'll name this review.txt, right? So now we can see it here in our console. And we're just gonna press save. Oops, sorry, let me just delete this one. Right, so we have review.txt, and it's actually empty right now. What we can do is we can go to imdb.com, and we can actually search for a movie and take a review from there. You can even write your own review to test your model, which is completely fine. But let's actually look for a movie. I'm gonna look for one of my favorite childhood movies, so Jungle Book. And not that one, this one actually, the cartoon. Right? And we're gonna go to the reviews, which are here. Right? So you can see that people write their reviews, 10 out of 10 movie. Again, if you don't watch it, go watch it. I would highly recommend it. So you can see like people write long reviews. So I'm gonna just pick one at random and just scroll down a bit. This one I know would be too easy, but let's see what this means. There's not a lot. The plot is rambling. I don't think this guy enjoyed the movie. We can actually try someone that actually enjoyed the movie. So might take me a second to choose. Good. I don't want something that's very clear, right? Let's actually go back to the top. Okay, let's actually take this one because it just seems nice. So we'll take this review and we'll save it here in our review.txt file, right? And then finally we can run this code. Yep. So we can run this code and it's going to go read the file, encode the review, and actually tell us whether or not the model predicts whether it's a positive or a negative review. Encode review. Oh, sorry, I forgot to define this. Right? Now we can actually call this function. There you go. Okay, so we actually had a small mistake in our code. You don't include items here. Sorry, that was just a Python syntax error. But when we do this, we can actually run this code again, and you can see that the review is first mapped to a certain to a sequence of integers rather, and then that's going to be fed into our neural network, and we can actually see that it's a 99.8% sure that the reviewer actually wrote a positive review about this movie, which is pretty fair because this movie is a 9 out of 10, right? Let's actually go and check something that's maybe 4 stars, so we can safely assume that they didn't like the movie. Was raised by animals. This is actually very neutral. Let's look for something with a bad note throughout the film was boring, blah blah blah, right? So this guy actually didn't like the movie for some reason, which is very weird. So let's actually make this all in one line, which is easier for our neural network. We'll save this and we'll run this bit of code again, and we can see that this is almost near 0, which is with the help of our sigmoid function, right? Because sigmoid actually pushes you either really close to 1 or really close to 0. So we can actually see that this movie review that this person rated 4 out of 10 is actually a bad review with our code. Thank you so much for watching today's workshop. We hope you enjoyed it and that you learned something new. For more similar workshops, consider subscribing to our YouTube channel and hitting the bell icon for notifications. Follow us on Facebook, Twitter, and Instagram at Make Smart Things. Also, we have a very interesting workshop coming up that will help you create an AR experience for IoT using the ThingWorks platform as well as Vuforia. Thank you, stay safe, and continue learning.